Okay, so this is going to be over section 7.1. If you come here to your canvas, you'll see here test 1 material 170 chapter 7 section 1. So it's better if you download that instead of just opening it. It'll be easier to read. So this is what your first web work assignment will be over, this material. Now on the first day of class, back Friday, more than a week ago, we talked about what it meant for an angle to be in standard position. So if it was in standard position, the initial side was on the positive x-axis. And then as far as the direction, if it moved in a counterclockwise direction, then our angle would be positive. If it moved in a clockwise direction, our angle would be negative. Okay. Then we also learned or reviewed about the quadrants. So the quadrants here, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And so the terminal side determines which quadrants it's in. So we can see here that the terminal side of this angle is in quadrant 2. And so we'd write it like that. This one we can see that the terminal side's in quadrant 3. Okay. Also, if you're talking about quadrants, we had some common angles. So all of this is review from the first day of class. Come here. So we have some common angles. So this angle is 90 degrees. This angle is called the flat angle. It's 180 degrees. This angle, well, it's the flat angle and then 90 degrees more, so it's 270 degrees. And then a full revolution is 360 degrees. Okay, we can go more than a full revolution. What does that look like? Well, a full revolution, so it's a positive angle, so a full revolution is 360 degrees, and then we go a further 10 degrees. And so that's what 370 would look like, and that would be in quadrant 1. Similarly, what would negative 200 degrees look like? Where would that be? Well, it's negative, so we're going to have to go in a clockwise direction. So if I come here, that's going to be 180 in the negative direction, then I go a further 20. So it would look something like that. So initial side is the positive x-axis, and here's my terminal side, and my terminal side is in quadrant 2. Okay, so that's a review of what we did on the first day in class. Everyone should be able to complete this first question here. Okay, so obviously for 613 you're going to go past 1 revolution. Will you go past 2 revolutions? Well, 2 revolutions is going to be 360 degrees times 2, so 2 revolutions would be 720. So you don't quite go past full 2 revolutions. So you're going to have to break it down like into terms of 90 degrees of where you're going to be at. So if I wanted to know where is 650 degrees, what quadrant is it in? Well, I know that 650 is the same as a full revolution. Okay, plus if I go a further 90, that's going to give me 750. No, 450, my bad. Okay, if I go a further 90, that's going to give me 540. If I go a further 90, nope, that's 13. 630. Okay, so then I go a further 20. Okay, so 650, this is how you're going to have to split it up. It's equal to 360 plus 90 plus 90 plus 90 plus 20. Okay. And so what's that going to look like? I'm going to go 360 degrees in the positive direction, then a further 90, then a further 90, then a further 90, and then plus 20. So a little bit more there. And so that's what my angle 650 degrees looks like. And that would be in quadrant 4. Okay. So that should give you an idea of how to break these up. Okay, so if it's here, you have to go in the clockwise direction. So that would be negative 360. And then go a further 90 degrees in the negative direction, and so forth and so forth. So that would be 360 in the negative direction, a further 90 in the negative direction, a further 90, a further 90. So we would do negative 360, a further 90 in the negative direction, a further 90 in the negative direction, a further 90 in the negative direction, then a further 20 in the negative direction. And so this is what negative 650 would look like, and it's in quadrant 1. Okay. Okay, so if we come here to this problem 2, they want you to convert from radians to degrees. Okay, well, the only thing you have to remember about this is that 180 degrees is the same thing as pi radians. So if you think of this as a fraction, that would be equal or equivalent to the number 1, and that would be equivalent to the number 1. Now, notice I didn't write rads. I could. The convention is not to write anything. Okay, so I'll write it in there for now, but more commonly it doesn't. You don't need that. So let's convert 120 degrees into rads, into radians. So You want to get rid of degrees, and you only want to be left with radians. So that's the one I'm going to choose. I'm going to multiply that by 1, and this is the way we're going to write 1. So you can see your degrees are canceling, and you're going to have 120 pi over 180 rads. That's not in lowest form. If you want to get that in lowest form, 120 divided by 180, you can do that in your calculator. 120 divided by 180. Then do math and enter. So 120 over 180 reduces to 2/3. So this is going to reduce to 2 pi over 3 radians, or just 2 pi over 3. Now, how would you type that in WebWork? You'd have 2 pi over 3. Okay, so just use pi for pi. Now, what if we want to go the other way? What if you're told to convert 2 pi over 3 radians into degrees? Well, you're going to want your rads to cancel. So you're going to choose this way to multiply it by 1. So your rads now will cancel, and I'm going to be left with degrees. Now my pi's cancel. Can you see that? And so I'm going to be left with 2 times 180 in the numerator, all divided by 3. And again, if you put that in your calculator, 2 times 180 is 360, and 360 divided by 3 is 120. Okay. What if you have something like convert 10 rads into degrees? You still want to get rid of rads. So you're going to want the fraction where the rads are in the bottom. So that's what we're going to use. And so on the top, I'm going to have 10 times 180 over pi degrees. And my exact answer, if I'm typing this into WebWork, okay, would be that. Okay. Now, we had that we had this, so we can get some common angles now in radians. So obviously, we know the flat angle is 180 degrees. That's the same thing as pi radians. And again, the convention is not to even put rads. So 90 degrees, well, it's half of the flat angle. So in radians, that's going to be pi over 2. And of course, we had that in degrees. Now, what would that be in radians? Well, it would be pi radians plus a further pi over 2. And I'm going to get 3 pi over 2. And then finally, we know a full revolution is 360 degrees. Well, it's going to be 2 of the flat angles, so it's going to be pi and a further pi So full revolution is 2 pi radians. Okay. So if you're asked what quadrant is the angle 3 pi over 4 in, well, that's a positive angle. And what do we know about 3 pi over 4? What do we know about 3/4? 3/4 is between a half, which is between 1. And so now I can just stick a pi in there. So here's my angle pi over 2. And then here's my angle pi. So this is going to be between pi over 2 and pi. So this is going to be in standard position. It's going to be over in this quadrant. And so that's going to belong to quadrant 2. Okay. What if I do negative 3 pi over 4? What quadrant's that in? Well, where's it going to be? It's going to be somewhere between negative pi over 2 and negative pi. So it's going to be somewhere in here. So its terminal side is in quadrant 3. Okay. So let's have a look at some of these questions. Okay, everyone should be able to do the conversion. Okay, so we just wanted to convert to radians to degrees and then degrees to radians. Now we come to a reference angle. So we have a couple of questions there on reference angles. Problem 3 and problem 4. Problem 3 is in degrees. Problem 4 is in radians. So let's go back to this. So we have some examples there in your notes. What does a reference angle mean? So let theta be an acute angle in standard position. A reference angle is the acute angle formed from the terminal side and the nearest x-axis. So we can see here with this angle, here your angle theta is in quadrant 2, and it's going to be the acute angle formed from the terminal side and the nearest x-axis. It does not have direction. It's always positive. It does not have direction. Here, the reference angle is going to be, the definition says, the angle formed from the terminal side and the nearest x-axis. That is your reference angle, and it's positive. It doesn't have direction. It's an acute angle. Here, by definition, the reference angle is formed from the terminal side and the nearest x-axis. That's your reference angle. And here, reference angle is formed from the terminal side and the nearest x-axis. That's your reference angle. Okay, so let's have a look at these. Find the reference angle for these. All right. So I'm going to copy this. Okay. Over here. All right. So let's look at the first one. Let's look at 35. All right, 35. It's positive, so it's going to be somewhere in the first quadrant. So that's my angle. Now, what's the definition of a reference angle? It's the angle formed from the terminal side and the nearest x-axis. So my reference angle is also going to be 35 degrees. Okay, so that one's easy enough. Okay, let's go on to the next one. What about 350? Well, 350 is just 10 degrees short of 360. So it's positive, and I'm going to come just short of a full rotation, full revolution. So that's what the angle looks like. So the reference angle is the angle that the terminal side makes with the nearest x-axis. And a full revolution is 360. So this red angle here is going to be 10 degrees. And it will always be positive. Okay. So my reference angle is 10 degrees there. Okay. All right, let's move on. Now what about this? We are going in the negative direction. So I'm going to go minus 90 degrees and then a further 40 degrees in the negative direction. So it's going to stop somewhere there. So my terminal side is going to be in quadrant 3. Now, what is my reference angle? It's going to be the angle made from the terminal side and the nearest x-axis. Now, if I come the whole way around the flat angle, that's 180 degrees. A different color. Okay, so that entire going that way is negative 180 degrees. So the difference there is going to be 45. But it's not going to be, yeah, because I think it is. Just take that. Okay. Now you got to be really careful here. Your reference angle is not negative 45. It's 45. The reference angle does not have direction. The reference angle is always positive. All right, so it should be 45 degrees. Okay. So let me just check these now. All right, so far so good. So let's go to these last ones. All right. What does the reference angle for these look like? All right. Now, how do I choose to rewrite this? 7 pi over 6 is the same thing as 6 pi over 6 plus pi over 6. And the 6's cancel. So, if I want to see where this lives, I'm going to go pi radians, and then a further pi over 6 radians. So just a little bit more. Okay, so this is what the angle 7 pi over 6 looks like. Now, what is the reference angle? By definition, the reference angle is the angle determined by the terminal side and the nearest x-axis. That is my reference angle. And if this is pi, then as you can see, the leftover bit here, the red part, is going to be pi over 6. So my reference angle is going to be pi over 6. Okay, so let's go back. Pi over 6. And then let's do negative 9 pi over 4. Let's see what that's going to look like. Okay. All right, first of all, let's ignore the negative sign. I'm going to choose to rewrite that as 8 pi over 4 plus pi over 4. And 8 pi over 4 reduces to 2 pi. Okay, so 9 pi over 4 is going to be a full rotation, and then you go a further pi over 4. So negative 9 pi over 4 is going to be a full rotation in the negative direction, and then you go a further pi over 4 in the negative direction. So negative 9 pi over 4 is going to be negative 2 pi. All right, so in the negative direction, so clockwise, then a further pi over 4 in the negative direction. So this is the angle negative 9 pi over 4. So we went negative 2 pi, and then we went, do a green, a further negative pi over 4 to get negative 9 pi over 4. Now the reference angle is the acute or the positive angle made from the terminal side and the nearest x-axis. That is the reference angle. It is always positive. The reference angle is pi over 4. Okay, and so we can come back over here. Okay. So everyone should be able to get these. So you should draw those and work out which quadrant they're in, and then work out what the reference angle is. You should draw each of these, work out which quadrant they're in, then draw the reference angle and work out what that is. Okay, so let's look at problems 5 and 6. That comes to these formulas in yellow. These formulas are not given on the final. You will have a formula sheet, but you won't have these formulas. You must memorize them. So what is an arc? All right, so if you have a circle, let's see if I can draw a circle. Okay. And it has radius r. And then you're traveling in a positive direction, and your angle theta is in radians. And so the angle that I'm going to make is here. And if that's a radius, this is also a radius. Then the arc is this distance, this curved line. If you could take this blue bit and pull it straight, it would have length equal to r times theta. But what you have to remember is theta has to be in radians. Then the area of the sector is going to be what I'm coloring in red here. And it has that formula. But again, theta must be in radians. Has to be in radians. Okay. So let's have a look at some of these. Let's look at that one. Okay. Well, we have our formula. Okay. If you memorize that, that's one thing, but it is wrong for this one to do that because that's not in radians. So we've already done this. For this, theta is equal to 2 pi over 3 radians. So this is going to be r, which is 3, times 2 pi over 3. The 3's cancel and you're going to get 2 pi. And if you're going to type this answer into WebWork, type in 2 pi. And that's the exact answer. Okay. If you have this. Okay, again, you're going to have to change that into radians. And there's a formula that you have to know. So once you've made that change, you're going to have 3 squared, and then you're going to have that. So in the numerator, you're going to have 3 squared, which I'm going to write like that. And in the denominator, you're going to have that. So your 2's are going to cancel. One of your 3's is going to cancel. And you're going to be left with 3 pi, which you type that in. So let's look at 78 and 86. 78, the exact answer was 2 pi. And 86, the exact answer was 3 pi. So you can see that. Okay, and one like this, number 90. If all you have is a picture, well, remember, if you want to find S, but you're going to have to change 50 into radians. And how are you going to write 1? Well, you want the degrees to cancel. You want the degrees on the bottom. So that's going to be 5 pi over 18. So S is going to be R, which is 9, times 5 pi over 18. And 18 is 2 times 9. So the exact length of S is 5 pi over 2, which you can type that into web work. So let's look at S for number 90. Oh, didn't have the answer to number 90 put in there. Okay, but that's how you do it. Okay, so that should be enough work through examples where you should be able to finish your web work. Okay, so here theta is 4 radians, so there's nothing to change. Here, your angle's 272 degrees. That has to be changed. Okay, you're going to have to change that into radians and get your formulas out. Okay, so that ends the video, and you should be able to complete 7.1.